Now this next set of problems in the limits review have to do with trigonometric limits. And as with algebraic limits, the first thing that we want to do is try to plug in the value that we're approaching, the x value that we're approaching. And we get limit as x approaches pi over 4 of 3 cosine x. And so that'll be 3 times the cosine of pi over 4. And the value and cosine of pi over 4 is just root 2 over 2. Next, number 8. We have the limit as x approaches 0 of 3 times x over cosine of x. So we plug in x equals 0. The numerator becomes 0, but the denominator is 1. And so that's really just 0 over 1, which is 0. The limit exists, and the limit is 0. In the next question, limit as x approaches 0 of 3 times x over sine x. Well, you recall that that looks very much like the important limit as x approaches 0 of sine x over x. It's just flipped upside down. But if that's 1, then it really means that the ratio of sine x over x is that those values are the same in order for the ratio to be 1. So it doesn't matter if we flip that over. The reciprocal of 1 also is still just 1. And then when we multiply that by 3, we get 3. Next, number 10, we have limit as x approaches 0 of sine of 3x over sine of 8x. And what we're going to do with this is to split this up, so I'm going to divide top and bottom by x. I'm trying to get it in the form sine x, sine of something over the same thing, limit as x approaches 0. So I first divide top and bottom by x, and then I need to get a 3x in the top fraction in the denominator, but then I have to multiply the numerator by 3 over 3, and that's just like multiplying by 1. The denominator, I want 8x, and so I multiply its numerator and denominator by 8, and now the sine 3x over 3x, limit as x approaches 0, is 1. And we're going to multiply that by the 3 on the outside. So we get 3 times 1, and in the denominator, sine 8x over 8x is also 1, and we have 8 times that. And so we ended up with 3/8. Now it just happened that you can see that answer clearly in there, but how we get there is not as simple. You can't just bring out the 3 and the 8 and then divide the sine x. You'd have to do it the way that I've done it here. But having said that, you can see that it actually does come out to be that answer, just 3 over 8. Number 11, we have a similar type thing. Remember that another one of our important limits is the limit as x approaches 0 of tan x over x, and that's also 1. So similar to problem 10, we're going to divide top and bottom by x. So we have the limit as x approaches 0 of tan of 7x over x divided by sine of 5x over x. But in order for our special limits to work, we have to have tan 7x over 7x. So I'll need to multiply numerator and denominator by 7 in the numerator, and numerator and denominator by 5 in the denominator. And when I do that and rearrange the numerator, I get 7 times tan of 7x over 7x, which I know to just be 1. Tan of something over the same thing is going to give you 1, limit as x approaches 0. In the denominator, I'd have 5 times sine of 5x over 5x, and we know that that limit as x approaches 0 is also 1. And so we end up with just limit as x approaches 0 of 7 over 5, and that is just 7 over 5. Problem number 12, we have the limit as x approaches infinity of sine of x. Well, sine continues to oscillate as you go out to infinity. It never reaches a limiting value, and so the answer to 12 is simply does not exist. And I'll continue with problem 13 in the next video.